And good morning. How's everybody doing today? Hope everybody's doing well today. All right, it is Dr. Roddenberry coming to you from my home office here in Willow Springs, North Carolina. We're going to be talking about the second half of Chapter 7 today. So we focused on behaviorism the first 2 days of the week, and then of this module, and then yesterday we talked all about a model of how the mind might work. I introduced you to the Atkinson-Shiffrin model of memory, and we talked about these different memory stores and how people use and manipulate information. Today we're going to go back in and talk a little bit more about memory, and we're going to talk about the fallibility or the human qualities that characterize the human memory as compared to computer memories. I see we have some people in the audience. Gustavo's here today. He's probably excited and getting ready for his trip to Dominican Republic. Gustavo, I had a student in my 118 class last night who is from the Dominican Republic, and she was just so sad that you couldn't take her back home as well. So she was also missing the DR. Marcella, good to see you. Thank you very much. And Salem, good morning to you as well. Great audience today. Thank you very much for coming. So we're going to talk a little bit about memory today. We're going to talk about the different types of memory stores, how we relate different types of memories to different parts of the brain, and then we're going to talk a little bit about the reconstructive memory. Hopefully today's okay, excuse me, there was a disconnection. There was a disconnection in the video stream. Hopefully it's better now. Okay, so remember when we talked in Chapter 2 about brain modularity, and I suggested to you that we could think of different parts of the brain as being responsible for different functional abilities that humans had. Remember? Good morning, Lewis. We're just talking a little bit about the areas in which memory is controlled. So if you remember, I talked to you about Broca's area and Wernicke's area. Two spots very important in the left hemisphere that are responsible for language. We then talked about the motor cortex, a strip in the back part of your frontal lobe which controls the basic motor movements of your body. And then I suggested to you that your cerebellum is there to coordinate all your motor movements so that you move smoothly and gracefully. And so we talked about modularity within the context of all these different abilities. Well, you can use the same concept when you think about memory in cognitive psychology. We might ask the question, is memory one thing and therefore processed in the same part of the brain? Or should we think of your memory as being modular as well? So, do we have one type of memory in one spot for memory? Or do we have many types of memory in many spots for spots in the brain responsible for memory? And what I will suggest to you today, what my thesis is going to be today, is that there are, in fact, many different types of memory stores in the brain, and these memory stores are kept in different parts of the brain. Well, and one of the main ways that we've done this is by correlating brain damage with people's specific memory disabilities. Now, probably the oldest discovery with regard to memory was discovered in this patient named H.M. Henry Moliason. Now, there are two kinds of amnesia that people suffer. Amnesia is an inability to form a memory, to use your memories, right? And so retrograde is when memories before the accident are inaccessible. So sometimes people get in a car accident and they lose their memories for things that happened before the car accident, but they can still learn and remember new things. And that's called retrograde amnesia. On the other hand, there are some people who may have an accident or a problem with their brain, and they can remember things that happened before the accident, but they can't form new memories, and we'll call that anterograde amnesia. So, one of the first things we learned about memory came based on this idea of retrograde versus anterograde amnesia. This guy named HM was given brain surgery because of severe epilepsy that the doctors were having trouble treating. And they took out his entorhinal cortex and specifically his amygdala. And it had a very curious effect on his memory. I see we have Andrea and Nicole dropping in to say hello this morning. Hi, how are you doing, Andrea? Thanks for coming today. It's always great to have you in class. Always great to have you back. I was just talking about Henry Molaison and talking about the value of the hippocampus in memory. So, if you'll notice, and good morning to you, Heaven. Thank you for checking in. And I'm looking forward to having you in my developmental psych class as well. Students, what you're going to hear is lots of students in my intro class go on to take the developmental class because they like this class style so much. And Andrea is one of my big fans. I hope you like developmental psych as much as you like introductory psych, Andrea. Okay. All right. And while I've noticed that my developmental class for the fall is full and there are 5 people on the wait list, if you were to sign up and fill that wait list up with people this summer, I'll bet you my boss would give that to me as an overtime class. So I am due one more overtime class. And if I had 20 students on my Psych 241 wait list, that's probably... And I have got to figure out why. I got my new laptop back and it started disconnecting from the internet. And I'm not exactly sure why, but I do apologize for that. Okay, so we're back to brain modularity. So with this guy, HM, he had these really bad seizures. Doctors went in and operated on his brain and removed this brain structure called his hippocampus. And what happened was this guy, Henry Molaison, woke up and he was not able to form new memories. He could remember stuff that happened before the surgery, but after the surgery, he was never able to remember, to learn another fact that he could remember. Now, you could tell him something, and as long as he was talking about it, he could remember it. But as soon as he stopped thinking about it, whereas for you, information goes to your long-term memory, his information never went to the long-term memory. If you remember that model from yesterday, I talked about the short-term and the long-term memory. And I suggested to you that when you're actively thinking about something, it's located in your short-term memory. And if you rehearse that information properly, it will be encoded into your long-term memory. Well, the brain structure that encodes that memory into the long-term memory is the hippocampus. So if you destroy the hippocampus, a person can no longer encode information into their long-term memory. Now, here's the deal. The memories that they've already formed are still there. So we know that the hippocampus is not where the memories are stored. They are just processed through there. And I'm even going to offer you a word for that process of encoding a memory on your long term. We call that consolidation. Anytime you access a memory and think about it, you are consolidating it again, or what we would say reconsolidating that memory. So every time you bring a memory up and you think about it and you rehearse it, you are encoding it on your brain again. You are writing it down. And so the more times you consolidate a memory, or the more times you reconsolidate a memory, the stronger that memory will get. So You folks have probably had the experience. Maybe there's a memory from your childhood that was really valuable, and you've probably talked about it a bunch of times. And you will never forget the details of that memory because every time you bring it up, you consolidate them in your long-term memory. And I really, really, really wish I knew what was going on with my internet. This makes me so mad. But let's start off our lesson by saying that the one thing we do know is that the hippocampus is the part of your brain that helps you remember memories. They don't stay there. They are processed through there. Okay? Now, let's then look at the types of memories that people lose. When people do lose memories for things that happened to them earlier in their life, which types of memories do they tend to lose? And can this tell us anything about the structure of memory in the brain? Well, yes, there is. And the next distinction I want to make, okay, is between what we call explicit memories and what we call implicit memories. All right. Implicit memory, anything you know how to do by memory, is an implicit memory. Do you know how to dial a phone? Absolutely. Do you know how to drive a car? Absolutely. All of those are memories that you have stored in your brain. All right. So the first thing we need to do is remember that memories aren't just facts for like George Washington or Patrick Henry. They are, in fact, any remembered activity that you can repeat. So riding a bike is a memory. Driving a car is a memory. Using a cell phone is a memory. But those are what we call implicit memories. You don't really have to consciously be thinking about how to ride a bike in order for your memory of how to ride a bike to take over. You don't really need to think about how to dial a phone. You just dial the phone while you're talking to me. These are memories that you can access and you can use, but you don't necessarily have to be conscious of these memories. Does that make sense? That's what we call an implicit memory. And then the second type of memory is the memories for facts that we test for here in school. I'm going to ask you to tell me who B.F. Skinner was. I'm going to ask you to remember in what country IQ tests were first invented. I'm going to ask you to remember lots of facts. Any fact that you can remember is what we call an explicit memory. And we call it an explicit memory because you can only use it if you think about it consciously. So, George Washington is not affecting your behavior until I ask you to think of the first president of the United States. You then bring that memory into your conscious awareness. Now, why is this important? Well, because what we found is there's a big distinction between implicit memories and explicit memories. Implicit memories are going to be controlled by your rear brain structures. So your cerebellum, knowing how to ride a bike, knowing how to use a phone, knowing how to turn the pages of a book. These are all memories that are controlled by your cerebellum, And damage to the cerebellum will lead to the disruption of these well-learned behaviors. Now, one other implicit memory that I want to talk about that maybe you don't really think of. But classical conditioning is a memory that we have. Classical conditioning is a memory. When little Albert learned to be afraid of white rats, that was a learned emotional memory. And the part of your brain that is responsible for that is the amygdala right here attached to your hippocampus. So damage to your amygdala in the hippocampal area surrounding it can lead to the loss of classically conditioned responses. All right. So implicit memories are things like remembered emotional responses. I remember that I'm afraid of that snake. I remember that I'm afraid of heights. okay? And memory for how to do things. I remember how to ride a bike. I remember how to use a phone. These memories are not memories that I really have to think about consciously for them to affect me. They're what we call implicit memories, and they appear to be controlled by the rear parts of the brain, the cerebellum and the amygdala. Now, your temporal lobe and your frontal lobe are where your more explicit memories are. And you know what? We're going to divide these as well, because there are some people who will have will experience an accident and will lose their knowledge for things that happened to them recently. You can think of a memory that you were involved in as an episodic memory. Do you remember eating dinner last night? What happened when you ate dinner last night? Your knowledge of what happened at dinner last night in your house is an episodic memory. That's a memory about something that happened to you. If I ask you to tell me about your first date ever, and you could tell me what you did with your first date, that would be an episodic memory. We're going to differentiate that from semantic memories. And a semantic memory is just a piece of abstract knowledge that you have. What does a triangle look like? Can you draw a triangle from memory? If you can remember what a triangle is, if you can remember what a cell phone is, if you can remember who George Washington was, those are what we would call semantic memories. And the crazy thing is, there are some people who have damage, who get in accidents, and they will lose their episodic memories for a while. They'll have amnesia. Something is clearly not right with the network on this computer. I didn't have this problem all week last week when I was using that other computer. So I got to figure this out. Yeah, I think it's this stupid computer that I have. My WakeTech laptop doesn't work very well, Andrea. And I think that's my problem. And so I don't know what to make of it. I had to, this computer broke last week, and I had to send it in, and I used a loaner computer all week long. It didn't have a single bit of internet problems, so I don't know what the problem is. Well, I do know what the problem is, but it's something to do with this damn computer's internet. So here's the deal. So some people will actually get into a car accident and lose memories for things that happened to them the week before the exam. They will lose what are called their episodic memories. And that's a memory for things that happened to you. And then, but these people will still remember what a phone is. They'll still remember who George Washington is. They just won't remember what happened to them in the last couple of weeks. That's the loss of what we call episodic memories versus semantic memories. And you know what? I even want to suggest maybe a third memory store that people typically don't, that's not talked about in your book, called self-knowledge. Because there's a form of amnesia when people forget who they are as a human being. Not just what happened to them in the last week, but they actually forget their own identity. This type of amnesia is usually stress related, and it's called psychogenic amnesia. And occasionally people will just forget their own identity. And so you can think of these semantic memories, these episodic memories, and self-knowledge of who you are as more of your temporal lobe events. And I would say your self-knowledge is probably in your frontal lobe along with your personality, okay? And so what I want you to understand is that it's best not to think of memory as one thing. Now, where exactly semantic versus episodic memories are, I can't tell you that exactly. We just know that damage to temporal lobes affects semantic and episodic memories. But whether or not they're separated, how they're separated, we do not know in cognitive neuroscience. But what I want you to understand is that just like every other functional human ability, memory is modular, and we have different memory types of memory abilities that are controlled in different parts of our brain. Our hippocampus is responsible for helping us learn new memories and put them somewhere in our brain. Okay? Behaviors that you know really well, like how to play a guitar or how to walk or how to ride a bike, are controlled by your cerebellum. Emotional fears that you learn, our memories, are controlled, are stored in your amygdala, and memories for events and facts that you know are stored in your temporal lobe. And we do know that people's memory systems for facts and episodes are different because we've seen people who will lose episode memory but not factual memory. Can you lose your ability to speak two languages? Wow, that's a great question. No, Marcella, I don't think you can, because language is going to be distributed so widely over the brain that any specific damage is not. It's not like you have a French circuit here and you have your English circuit here, and one of them gets damaged. English or any language is processed over the entire parts of the brain. Now you do have your motor and your grammar center, but those areas then connect. All your memories for words are in your temporal lobe, and your memories for yourself are in your frontal lobe. So when you're talking, you're calling up all of these memories from different parts of your brain, because that's what your language is made of: memories and ideas that you remember, and you put them all together. So language, the actual type of language you speak, is going to be controlled by lots of the different parts in the temporal and frontal lobe. And so the damage that would take one language would probably kill you. That's a really great question, Marcella. Brilliant question, actually. Okay. Now, here's the second thing the next lesson I want you to get from this lecture. What exactly is our memory? Now, if you've ever saved a document onto your computer hard drive, your document is being remembered by your computer. Okay, you are saving a document. Basically, you are saving it in the computer's long-term memory. And in a certain sense, human beings save memories on our temporal lobe, which is our hard drive. So you can think of computers and human beings as both saving things in their memory banks. The computer has a hard drive, the human being has a temporal lobe. So, in a sense, anytime you can remember something from a long time ago, you have saved it onto your hard drive, just like a computer has saved a file, a document you wrote, onto its hard drive. All right? Now, that's where the similarities end. You need to understand that the making of a human memory is different than the making and the retaining of a computer file. All right? Now, when we think of memories as being something we pull out completely and in an intact format, that is actually not true. What we do is we reconstruct memories. We remember the kernel of the memory. And then as we're asked to pull out details, those details may or may not reflect what actually happened. Every time we remember something, we change a little bit of that memory. So we don't actually remember things, we reconstruct things. And when you are reconstructing something rather than resurrecting it completely as a whole, what you're going to find is that what you've saved has changed a little bit. Imagine if you saved a Word document and when you came back it was written in red ink and you had saved it in black ink. What if you saved your paper on in Microsoft Word and it changed all of the nouns to the French language, or it changed all your nouns from people to fishes. What if every time you reopened a Microsoft Word document, a PowerPoint slide, you found that the computer had changed some of the words and the things that you had said? That'd be a little bit annoying. However, that's what happens to people's memory. But it happens so smoothly, it happens so automatically that you don't realize it. And most people think they have perfect memory for events that happen to them. The actual deal is people's memories are always changing and never perfect representations of what exactly happened. Now, if you look here on this slide, there are 4 different general lines of research which which demonstrate that people's memories are not as perfect as we think they are. And what I'm going to do is start by talking about the first one right underneath me, known as which is which demonstrates the power of suggestibility in memory. There is a really famous memory researcher named Elizabeth Loftus. I think she's at Harvard now. And she did these really cool demonstrations showing how you could change a person's memory based upon how you ask them the question. So I'm not sure if which experiment this video comes from, but the gist of her experiments was she would show her students, or show the research participants, a video of small fender benders or car accidents. She would show people these accidents, a video of these accidents. She would then send the people home for 3 days, and she would bring them back 3 days later, and she would ask them questions about what they had seen. And she found that she could get very systematic differences in students' responses based upon how she asked them the question. All right? So what she would do is she would ask the people if they saw broken glass, but she would change the question one of 3 ways. She would ask 1/3 of the students, did you see broken glass when the cars collided with one another? Did you see, she asked 1/3 of the students, did you see broken glass when the cars bumped into one another? She asked another 1/3 of the class, did you see broken glass when the cars collided with one another? And she asked a third group of students, did you see broken glass when the cars smashed into one another? And what she found, actually, you tell me, what do you think she found when she asked that question the 3 ways? Which group of students do you think was most likely to remember glass? The group of students she asked, the group of students to which she said bumped, the group of students to which she said collided, or the group of students to which she said smashed? There were different responses. Which group do you think was most likely to see glass? Smashed. Now, can somebody explain to me why that might change your memory? Why would the way you ask the question change the memory? Why would that possibly happen? Right? She would also ask the same question. She would also use the same word, same difference in words, but she would ask them how fast the cars were going when they bumped into one another, when they collided with one another, when they smashed into one another. And what she found is that people would vary the amount of speed that they estimated the cars were going at based upon the word. Exactly. But that is exactly right. It makes it seem more or less extreme, but that's not part of the memory. In a sense, what I'm doing is I'm using my word to color your memory, right? The pathological would happen usually in an accident site. Exactly, Lewis. Andre and Lewis. Both of them are talking about situations where the person adds something into a memory. We typically think about pulling a memory out clean, but we don't do that. We go in looking for a memory with a certain expectation. And Lewis and Andrea both sort of bring that point that we take our own expectations when we go in and start building a memory. And so these people built the memory they changed based upon how they were actually asked about this question. And good defense attorneys learn how to use this to their effect when they question people about events that happened in a legal case. Association of words, yes, you can suggest the memory. Exactly. And by saying suggesting, I'm saying I'm helping you create a new memory. So we call that, or that falls under the category that sometimes memories can be affected by suggestion. And this is the Elizabeth Loftus experiment, very famous experiment from the late 70s. Now, here's another nifty thing. It turns out that Elizabeth Loftus demonstrated you could plant completely false memories in someone's mind as well. So what she would do is she would find people that she was going to use for her memory study, and she would talk to their family members, and she would get a couple of stories from their past that had really happened when they were young. So let's say I'm talking to Lewis, and I talked to his mom and dad and found out some stories that he's going to know about because he was there. They happened to him when he was a young kid. And so what I'm going to do is I'm going to bring Lewis into the lab, and I'm going to say, hey, Lewis, do you remember this? And I'm going to tell him a story about something that really happened to him. And Lewis is going to say, yeah, I remember that story because it really happened to him. And then I'm going to say, hey, Lewis, do you remember this other story? And I'm going to tell him what happened. And he's going to say, yeah, I remember that story because it really happened to them. Well, then what Elizabeth Loftus would do is she would say, hey, do you remember that time you got lost in a mall and your parents weren't there and you were crying for them, and this old man came and found you and took care of you till your parents came? And what she found is that she could get a majority of the people to remember this false memory had happened to them. What she did was she told them about two memories that had happened to them, and she then planted in this third memory that hadn't happened. But because she'd got them in the idea of accepting these memories that had happened to them earlier, she managed to plant a third false memory into people's minds. All right, being lost in a mall did happen. Holy cow, it really did happen to Lewis. Okay, well, there you go. I was able to guess what happened to you early in life. Are you sure it happened to you, Lewis? Maybe somebody planted a false memory in your mind. All right. And so these are two ways in which human beings can have incorrect memories put into their brain. I can ask you, the way I ask you about questions is going to cause you to change the memory. So if I ask you, how much fun was that party last night? That use of that word fun is going to make you remember the fun aspects of the party. And if I ask you, hey, how was that boring party you went to last night? The word boring is going to affect the kinds of things that you remember from the party. So the way I ask you the question is going to affect the way you remember the party. Or in some situations, if I use the right context, I can actually cause you to create a memory or accept a memory that never actually happened to you. Yes, absolutely, Marcella. Like a fake collective. I would say so. When they use those cultural tropes in commercials, the family eating dinner around a table, that may cause you to think that your family has those kinds of memories, which maybe it does, maybe it doesn't. And you're right, by sort of activating those cultural memories we have, they may create in us feelings and memories. Yes, absolutely. Advertisers are evil that way, right? Okay, now, here's another nifty phenomenon that demonstrates that memory is kind of malleable, and it's called source misattribution. Now, it is generally believed that human beings, that the temporal lobe that myelinates memories isn't matured until the late second year, early third year. So what we know is there is a phenomenon known as infantile amnesia. People just don't remember what happened to them before about the age of 3 or 4. It's just not possible. The mental material is just not matured enough. The neural material is not matured enough. The hippocampus isn't myelinated enough to put these long-term explicit memories in your brain. However, every time I say that, a student will say to me, Chris, that's wrong. I clearly remember something that happened when I was a year and a half old. I clearly remember my second birthday party. And people will often challenge me by telling me that they have a memory from before the time when they were 3 years old. And here's what happens more than likely. What happens is your parents told you about this memory later in your life. And it was probably so funny that your parents told it a couple of times. And what happened was you then walked into this memory that you hadn't been aware of and you adopted it as your own memory. There are lots of demonstrations of people who will hear a story from one person and then later on they will remember that event as if they actually experienced it. That's what's known as source misattribution. So, a memory for an event is itself, and whether or not you were actually there is just a piece of that memory. And so, it's very easy for sometimes for people to take that last piece themselves and put it into a memory. So, I might tell you about this great party that went on last week. And if me and my friends talk about it 3 or 4 times in front of you, 10 years down the road, somebody asks you if you ever went to a crazy party, you will actually say, yes, I remember this party that happened, blah, blah, blah. And you might actually use the memory that I or your friends gave you. This is what's known as source misattribution. And then a lot of times, people will change their memories in such a way to reflect their new attitudes and opinions. So I was uh, uh, so if I was very, very liberal as a 16 or 17-year-old kid and did lots of liberal things, protest marches, this and that, uh, I might have those memories. But let's say I grew up and I became a conservative Republican. Suddenly, I'm not going to remember those things I did that were consistent with my liberal past. Instead, I will remember the times I saluted the flag, that I will remember July 4th parties. I will remember all the times I talked about the military. So what tends to happen is people's memories tend to change in ways that become consistent with their changing attitudes. So what these 4 things demonstrate, and I'm going to want you to be able to identify examples. So on the exam, I have examples of these different memory limitations, and I'd like for you to be able to identify a spontaneous false memory that is planted, or suggestibility. I'd like for you to know Elizabeth Loftus's study. I'd like to know what it means when you demonstrate source misattribution. So I might ask you examples and want you to know about these specific limitations. But basically, what they demonstrate is this larger principle, which to me is the most important thing. Your memories are not perfect representations of your past, even though you are absolutely sure that Tina was wearing the red shirt, that Alvin was the one who started the fight, even though you think you are absolutely sure about the details in your memories. What I want you to understand is that you are not. At the very least, you have minor inconsistencies in your story, because memory is reconstructive. It is not reproductive. You don't reproduce a memory, you reconstruct a memory. Okay? And so that's sort of all I wanted to cover today. I wanted you to know that memory is multiple things, and we know that by looking at brain damage studies and seeing that different memory kinds of memory abilities are destroyed based upon where brain damage occurs, and that when we do lose our memories, we lose it in really consistent ways that suggest these different types of memory stores. Explicit memories from implicit memories, emotional memories from behavioral memories, self memories from general semantic memories. And so I want you to understand that memory occurs in different places. And when we remember things, we just remember the kernels of things, and we add details in when we go back to remember these events. Like a fake collective memory. Absolutely, Marcella. It sounds to me, you sound like a matrix kind of person. It's all an illusion that is created by the overlords to control us. I like your thinking, Marcella. Okay, does anybody have any questions about today's lecture? We finished a couple of minutes early. Don't forget, exam 2 is available tomorrow morning at 9 a.m. And I will also be doing an exam review live on YouTube tomorrow morning at 9 a.m. Where I will go over the questions that will be on the exam and tell you you need to know this, 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 and this. The exam is going to cover chapters 4, 5, 6, and 7. So it's a pretty big test. It's going to be 60 questions, multiple choice, matching, true, false, the same style. And you're going to have 60 minutes to do the test. So don't forget that we have to do that. And remember, Marcella, I'm going to be looking for perfect memories, not made up or reconstructed memories. And that's why tests and exams are so much more difficult than real life, because I'm asking for you to get the details right? Are the types of memory some Mandela Effect works, or is it how the Mandela Effect? The Mandela Effect. Hold on, I'm Googling Mandela Effect. A Mandela Effect. False memories. Oh, yes, for having vivid and detailed memories and news coverage. Yes, absolutely. Absolutely. Some memories. Actually, you know what? I forgot. Did we talk about false flashbulb memories? The weird thing is, when important things happen, a lot of people tend to misremember important details about when they found those events out. So there's research to demonstrate that when you ask most people about, well, this is a little bit old, but they did this 10 years ago, 10 years after the 9/11 attacks in New York City, they asked people where they were when they had this memory. And it turns out that most people misremembered where they were when they found out about a really, really important event. And so people have these important memories. Sometimes people lose important parts of these memories, and they'll just remember. They'll forget important details on some of these memories. Now, false memories can sometimes be shared by multiple people. Huh. Huh. It is a false memory. Huh. That's weird. Yes. Yeah, absolutely. I'm sure if you're motivated by some sort of sensory experience, something's really important to you, you could remember that event. I'm going to have to do some reading. You kind of caught me off guard there. That's a good one. I haven't seen that. Uh, Thank you, Maria. You caught me. Now I've lost interest in class. Now I want to go read about the Mandela Effect and see if I can try to understand that from a psychological perspective. Good question. Good question. Stump the professor. I like it when you folks ask the questions I can't figure out or tell me about things I don't already know. That's exciting to me. I feel like I'm getting challenged. Can I have one example of how it's going to be the question of false memory on the exam? So I might say something like, I'm going to refer specifically to the experiment. In Elizabeth Loftus's study, she suggested that people uh, 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 ask people about their memory for a car wreck. What determined how fast they thought the cars were going? And you're going to say, and then one of the answers will be the way she asked the question will be something like that. All right, does that make sense? Sometimes people remember things that happened when they were 1 years old, even though, and they say they actually remember that, even though modern research suggests that they're not able to form memories at that age. What memory phenomenon describes this recreation of impossible memories? And and you'll answer that. Do you see how I would ask the questions, Marcella? I'm going to try to give you the clues to make you pick the right demonstration. So, let me go back to the PowerPoint presentation. So, if I want you, I say, you know what? Eric was a very liberal student when he was a teenager. Now, as a 50-year-old man, he's going quite conservative. If asked, Eric doesn't remember any of the protest marches that he went to as a teenager. What memory limitation is this demonstrating? And you'll say, oh, that's memory bias. Or I'll talk about planting a false memory by context, and you'll know spontaneous false memories. Does that make sense? I hope that was. Come to the review tomorrow, and I might even get crazy enough to read you the question out loud. How about that? Okay? I might even do that. Okay, cool. Yeah, sometimes I don't do the greatest job describing things on YouTube. Sometimes the questions, I have to write new questions every semester, so sometimes the questions aren't as good as I'd like, or they seem better when I write them and I come back and look at them later. So it's all a work in progress, and I'm doing the best I can. And if the questions don't make sense to you, you're always welcome to ask me to interpret them for you. Okay, it's a little bit harder with the exam going on, but if you were to text me in the middle of an exam, say, hey, I'm taking the exam and I don't understand this question, if I'm available, no guarantees, but if I'm available, I might can even help you on a question. Okay, good. Oh, there you go, Andrea. There you go. She was in all of my review sessions from another semester, so she gives you she's giving me the positive review. The 2 thumbs up. My TripAdvisor. Thank you very much for the positive review on TripAdvisor, Andrea. Okay, that's all I have to say for today. I hope everybody appreciated the lecture. I hope you understand these 2 very important things about memory, that it's modular and that it is also reconstructive. Don't forget your discussion board is due tonight at 11:59 p.m. Even if you come to the webinar, you can still score some extra credit by doing the discussion board as well. Remember, you have to post once and respond to at least 2 other people for a total of 3 posts in order to get credit for your discussion board. The homework number 4 is due tomorrow night, and this is exam weekend. So we have got a big Psychology 150 week. Hey, you folks have a great day. If you have any questions, don't hesitate to send me a text, or I can jump into Microsoft Teams and talk with you. Andre, it's good to see you as always. Thanks for coming back and sharing with us. And class, you have a great day, and I will see you tomorrow morning in the review session. Bye.